Nice. I see we have some people from the, more people are joining. I see we have some people from the US. Adrian from the UK?
Yep.
Hi there.
Hi, Stylianos.
Hey, what brings you here? Are you a data scientist? Are you?
No, I'm basically started an analytics business last year, serving private equity, looking at companies that are trying to sort of muscle in on the data that they've got to monetize. And I think over the next year, 18 months, I want to start looking at sort of machine learning and AI and how I can start really getting to grips with that side of things for automation, because there's a slight growing need for that. And I've come across sort of obviously DevOps and data ops a little bit, but we're more on the analytics side and we're learning. So yeah, it's a big subject. So taking it easy.
Yeah, well, I guess if you're learning, you're definitely in the right place. As you might know, we organize many events and workshops, most of them free, on all topics related to AI, data science, and other emerging tech. We're gonna have actually some events. We already started arranging some of the events for January, and we hope to have a very busy winter. Most of our, actually all of our events now are also online. Hoping maybe do some in-person events in maybe in spring. Obviously, that's not only up to us; it's also up to COVID, unfortunately. But it's the way things are. Let me share my screen in the meantime. Yeah, perfect. Let me see. Okay. So normally, what we do is we're going to wait for a couple more minutes, then we can get started. We have many registrations. We had many registrations for this event. We had close to 100 registrations, 98 actually, which probably demonstrates how popular this topic is. And as a data scientist myself, I can attest to the fact that project management methodologies for data science, they're a bit tricky. It's still an evolving field. So we need to, I think the community needs to really discuss these issues, and that's obviously relevant not only for data scientists, it's also relevant for decision makers, leaders. These are really the people, the audience of the Tesseract Academy. And quite often leaders, entrepreneurs, managers, they might feel a bit lost as to how they should manage these types of projects. And it's one of the reasons that we're organizing this event today. Okay, 23 people. And let's wait for a few more minutes and we can start. By the way, those of you who've not done this already, feel free to write in the chat and let us know where you're calling from and what brings you to the session. The better idea we have about our audience, the better the presentation can be. Nice, Geneva. Okay, so we have people from the US, UK, Europe. Nice. Anyone from Africa or Middle East?
Hey, Jerry, did you need any help getting in?
Sorry, okay, I think someone unmuted themselves by accident. Please mute yourselves while the talk is on. There's going to be a Q&A towards the end of the session where you can ask any questions that you want. The presentation should be about 30 minutes or so, and the event should be around 60 minutes or so in total.
I'm ready whenever you are, Stelios.
Perfect. Oops, here's one more person. So I guess we can get started. Let me run a very quick introduction into the Tesseract Academy. So first of all, welcome everyone. Thank you for being here with us. We're going to talk about a very interesting topic, which is relevant for both non-technical and technical professionals. A few words about the Tesseract Academy. The Tesseract Academy's mission is to help leaders better understand and use technologies like AI, data science, and blockchain. And we do this through a combination of services from workshops all the way to consulting and implementation. And we've worked with companies of all sizes. We've worked with solo entrepreneurs, some of their testimonials, you can see them here. But we also worked with bigger organizations like Vodafone, the US Navy, and British Land. And since our mission is to educate leaders and entrepreneurs and help them implement those technologies, we run all kinds of events, free, but also we also run in-house workshops, but we also provide online courses. So if any of you are interested, you can feel free to get in touch with us and we can share more details. I'm going to be your host and moderator for today. My name is Stelios. I've been in the space of data science and AI for more than 10 years. I'm the CEO of the Tesseract Academy, a startup advisor, and I'm also affiliated with some academic institutions like LBS, UCL, and Cambridge University. I've also written a book on the topic of data science for decision makers, which I'm more than happy to share with you as a PDF if you send me an email to the email I just shared. Today, we're very lucky to have with us Zane Harvey, who is an adjunct professor of computer science at Capital Technology University in DC. He's also a very experienced data scientist, and he's worked with companies of all sizes, from startups to Fortune 500 companies. And he's going to talk to us about agile methodologies for AI and data science. So I'm going to stop sharing my screen and turn myself mute. And the stage is yours, Zane.
Thanks, Stelios. Okay, well, welcome everybody. We have a pretty nice turnout here, and Stelios and I are really excited for that. You can see the slides here. If you have any issues seeing anything, please let me know and I could try to increase the magnification. But again, welcome everybody. This is a relatively short talk. We'll probably go 30 to 40 minutes on talking about Agile, which is a gigantic topic and a very popular and a very lucrative topic in the tech world today. But we're also going to apply Agile. Agile traditionally was just for software development. It's being now applied in the data science and AI and machine learning space. And we're going to talk about how the processes and procedures and methodologies differ just a little bit, and how they're the same when doing a machine learning model or an artificial intelligence project compared to a traditional software development project. So the title, Agile versus Data Science and AI Startups, my title, I just put there, technologist. At this point, I really don't know what else to call myself. I have a very broad background, teaching as in the computer science department at a university in Washington, DC, which is where I work out of. My background, basically physics, math, statistics, computer science, and also nuclear engineering. I work as an associate with Tesseract Academy. I work with Stelios for probably at least 2 or 3 years at this point. Also CTO of another tech company that's based primarily out of California, but we do have clients around the world. And then, as I said, I teach during the week, online and on ground at computer science classes at Capital Technology University. And I did see there are a few of my students in the audience, so that's great. If you want to see more of my website, just basically my CV is at zaneharvey.com. Okay, Stelios already covered all this stuff. So you're free to turn on your microphone, but also I will. Nice, Elijah. Elijah said, "Go Cap Tech." Give it some shout out there. It is a very well-run university in the DC area, and a lot of their students go on to work with the U.S. government and NSA and things like that. So very technical oriented and hands-on program, very good. So the Tesseract Academy still is already covered. So I'm going to kind of skip over this. He already did all this, and our goal is to basically help you. You know, if you have a place where you know you want to be and you can't quite get there on your own, we would like to hold your hand and help you get there and be your partner. So basically, we're very flexible in the format of how we do that, whether it's just one-on-one coaching, personal coaching, workshops, specialized training for your personnel. But basically, we want to help grow your business and help you apply these really exciting things that everybody is reading in the news about AI and data science and IoT and big data. How can they apply these things in your organization? And the workshops, like even today's workshop, these are pretty much aimed at decision makers, not necessarily developers and machine learning specialists and data scientists. We're more looking at helping leaders of companies, how they can leverage these things in their own company, whether it's even just hiring people that do these types of things. So the level of, it's not at a very super technical level today. We can certainly go there as needed or offline, probably, as far as you'd like to go. But this is more geared at people in the decision making and the executive suite. So, and that's how a lot of our products are geared towards. But we can obviously get as technical as you'd like to do. So, goals for today. I want to explain what Agile is and what it isn't. There's a lot of misconceptions about Agile, and it's a very big buzzword, and it's almost, I actually have some Dilbert cartoons in here that kind of show a lot of people have a bad taste of Agile. Maybe they were forced to do it, and they had to go to these meetings, and they didn't really see any results, and they didn't really think much of it. But we're going to talk about what it is and what it isn't, and also clear up misconceptions about common misconceptions about what it says you should or should not do. Agile really is not a set of procedures or protocols or rigid frame. It's not a framework that you follow. It's really a state of mind. It's a mindset about how to do technical work. It just happened to be developed for software development, and now it's being applied in data science and AI. And that's a little bit different of a workflow. It's still very exploratory. It's still very revolves around experimentation and exploration, the model building process. But it is a little bit different. Time estimates in data science projects are a little bit more difficult than traditional software features, So we'll talk about all that. How Agile can be applied to data science and AI projects. There's several popular frameworks out there. We'll talk about some of them, and we kind of have our own that we use, but everybody's kind of probably has their own that they've taken one and tweaked to their liking. One particular one is, well, two, they're cross-industry standard process for data mining, CRISP DM, and then also one I particularly like, the team data science framework there, TDSP. We're going to also talk a little bit about modern continuous integration, continuous delivery, which is kind of a must at this point. It's kind of and the tools that go along with it that can help facilitate that. At this point, there's kind of an old way to develop software, which I admittedly still utilize quite a bit when I'm definitely doing things unilaterally and I don't have a team to worry about. I may not use the best and most modern CI/CD practices, but certainly have the capabilities and certainly have used them. But there is kind of a more modern approach to developing software, which is quite different than just a traditional start with a blank slate and write your software and put it on the server type deployment. So talk a little bit about that and how we can do that at scale with tools like Kubernetes. Discuss current tools for data management, and also data versioning is something that's gaining a lot of steam. So if you think about Git and source code management, the breakthrough there was repository and allowing a common place for everybody to push their features and have agreement and have one single path that's the production. And then you have all these different kind of limbs that go off that are more exploratory, okay, call those branches. That maybe are trying out new features. Maybe they should be merged, maybe they shouldn't be, but some of them end up dead end. Some of them get merged back into the main production code. So we have kind of that type of tool for data as well, right? I mean, we know that any data science, any machine learning model is going to be only as good as the data that's fed into it. So how can we do the data governance, do the data, keep the data integrity, and make sure that we're using the same data when we're trying different models, so we know we're getting the same comparison, and also sharing. The idea of open data is very popular nowadays, and sharing your data, and how do you share your data in a consistent manner. We'll also talk about a really advanced, newer technique of feature stores, which is not only sharing your data, but also sharing the features that a data scientist went through all the laborious work to create the actual features, maybe aggregating various columns in different ways and things. And then allowing them a very easy way to share those features with other data scientists so they can use those as inputs to their models. Okay, so other things, what is Agile? Flavors of Agile, there's an endless list of flavors of Agile, okay? And I'm one that I'm very agnostic to the actual flavor or the actual, methodology that you pick, Scrum, Lean, Kanban, whatever works for you. The point of this talk is I'm going to tell you there's a list of, well, it's not a list, but there are several practices and really states of mind that if you adopt those and you apply those and you really internalize those, there's this kind of thing with Agile where a lot of people, they're walking through the motions and they're doing it, but they don't really get it. Okay, they're going to scrums and they're doing the stand-ups and whatever and the retrospectives, but they're not really internalizing it. They're not really seeing the benefit. And so, however, whatever you want to do in terms of meetings and we'll talk today a little bit about how Agile traditionally was really focused on in-person communication. Obviously, that's changed in the last few years and will probably stay that way somewhat. Actually have some data on that, and a lot of people aren't going to go back to the office full time. Obviously, they're going to do some sort of hybrid, and some aren't going to ever go back. A lot of developers, I don't think, will ever go back. So, this focus on face-to-face communication in today's world, how can you do that with things like Zoom and Teams and all of these, and even tools like Slack. So, and because one of the main things of Agile is stresses communication among all the different people that are involved. So how can you increase the communication and optimize the communication? So we'll talk about different flavors. Also scaled Agile. Agile was really meant for teams, smaller teams, maybe 5 to 20, somewhere in there, maybe a little bit more, but 8 to 20. But and really meant for specialized, experts, expert developers. It really wasn't. It's not really meant for people that are junior or learning. Obviously, they have a place, but it's really meant for a team of very even specialized or expert developers in particular areas to work through very quickly and turn out software products that have high quality and that the customer likes. Agile, how do we apply it for data science, machine learning, and AI? Software development versus data science and machine learning workflow. Workflows are different, but we'll also look at how they're the same. Tools and software automation. Everything today is about automation, and we've got to automate things like our feature engineering now, which is feature stores, and automate our CI/CD pipelines. And everything is about automation at this point. So how do you automate the workflow? And then wrap up, and then a Q&A. So from the advertisements, every business is a data business. At this point, if you're not leveraging, the digital transformation, it's been going on over the past arguably 20, 30 years, even longer. I don't know. Definitely over the past 20 years, companies have to transform into a digital business. And if they're not, they're left behind and they're not going to be able to compete. And if they're not doing these things and not staying up to date and using data science and analytics and things, they're not going to be able to compete. And so the digital transformation is no longer a want, it's a must. And that's part of what we help with. But every business has data. Okay, I don't care what you're doing, what you're selling, you've got data. And if you have data, you can analyze it and leverage it to make yourself better, make better decisions, make your business better. So every business, no matter how small, needs to have data strategy and be prepared to use artificial intelligence and really injecting, even a lot of legacy things. You can inject machine learning into legacy software and make it much, much better. So project management is, Agile is really just a project management technique. It's a way to manage people and teams to get things done, but it really focuses on the things that are the most important for developing quality software, and in what we're talking about, quality data science applications, and machine learning applications. Okay. What is Agile? So what are some of the special considerations applying Agile in data science? And what are the differences in Agile applied to bigger organizations, okay, compared to startups? So Agile flavors, there are many, many flavors. We can't cover them all today. I'm going to talk just in a very general sense of what it means to be agile, regardless of what flavor you use. You can pick whichever one you or your team wants to do, or your company forces upon you. But if you really internalize these things and strive to understand them and to actually do them, then I think you'll see great improvements. And not only you have to make sure everybody buys it. So we, the Tesseract team, are available to elaborate after the workshop. Again, we have limited time here. I'm already 22 minutes in. I have 243 slides, which about 200 of those are backup or so. So, but we are going to be pressed for time. What's going to happen is towards the end, we're going to say, hey, please take this offline, contact us, email us, and we'll continue the discussion. So what Agile is and what it is not. Have the obligatory Dilbert cartoons here. So I like the one at the top. We're going to try something called Agile programming, and the manager says that. And he says that means no more planning and no more documentation, just start writing code and complaining. And the engineer says, I'm glad that has a name, and that was your training. So the one on the right, the manager's walking out and says to his developers, I'll go out and find out what they need, and the rest of you just start coding. Okay, so this idea of what does the customer really need, that's the heart of Agile. The one at the bottom just emphasizes the iterative and the changeable nature of Agile. You can see the top 4 steps kind of go as maybe an assembly line and build to the end product. That's not Agile. Agile is very adaptable. So you start with one idea, and number one looks like a skateboard or something. And by the time you're done, you've got something totally different. And that's being Agile, is adapting to change, embracing change, and being able to change. This idea of a traditional waterfall approach where you have your requirements up front. We used to call that big requirements up front, where everybody sat down for weeks or months and had a lot of meetings and finalized all the requirements. And then they couldn't be changed. And they said, this is it, go off and build it. And then what happens is the development team loses touch with the original customers. And by the end, when they finally develop the product, it's not even what the customer really wants. So Agile is going to stress involving the customer at all phases and at all times and being part of the development team. Agile is not a rigid framework of meetings and project management procedures. Some people have a bad taste. They were forced to do Agile and didn't see any results. They didn't really get it. Okay. So we're going to talk about what it means to really be Agile. It's more than a buzzword, and rather than have you read all this, basically it's going to grow from a 15 million in 2018 to 63.8 billion market with compound annual growth rate of about 20% from 2019 to 26. There's a tremendous amount of training and this Agile landscape, which we're going to show. Even in the DC area, I talk to people all the time. There's tremendous demand for Agile training. Every company is feeling like if they're not Agile already, then they're really behind the 8 ball. So there is lots of training and lots of literature, and there's a gigantic environment and community online that focuses on Agile and Agile training. Obviously, lots of books and things. Common misconceptions. So no more planning. A lot of people think that we're not going to plan anymore. We're not going to do QA. We're going to change the requirements whenever we want. There's no discipline in Agile. A common critique of Agile is it's just chaos and there's no plan. That's not true. And another misconception, Agile is Scrum. Scrum is just one way you can do Agile. Another misconception that there's no more design, no more documentation. Very common critique of Agile. And again, I always look at both sides, and there are people out there who critique Agile and don't agree with all of it. But overall, I personally feel that the principles are extremely good in terms of building quality software and even quality data science and machine learning products. So again, nothing's other 100% perfect, but common critique of Agile is that it was just developers are lazy and they don't want to write documentation, and so they said we don't need documentation anymore, and that's why they want to do things like this. That's not exactly true, and we'll talk about that. Agile doesn't scale. It was meant for smaller size teams, but it can scale, and you can have scrums of scrums and basically have a hierarchy of teams in Agile, and it allows you to go faster. Maybe it depends. So what is Agile? Over here, I just have a picture. Being Agile is really about a state of mind. It's a philosophy or state of mind regarding how to create great software, and that's all it is. Okay, it's a mindset on how software should be developed. It doesn't matter which flavor or tools or protocols you utilize. It's really more of a state of mind. And you can see under the Agile umbrella I have here, Scrum, Crystal, XP, Kanban, and feature-driven development, and many others. Okay, these are all different ways that you could try to institute Agile in your organization. Okay, other list of flavor: XP, feature-driven development, test-driven developments. That's where you write your tests first. That's very popular. XP, extreme programming, Kanban, Scrum, Lean, Crystal, dynamic systems development methodology, Six Sigma, and many, many more. Okay, just to show you just how complex the Agile landscape is this was a infographic created by Deloitte. It's a little bit dated at this point, but as far as I know, it hasn't really been updated. 2016 is when this came out. You can see it is modeled after the London tubes, as from what I understand. So you can see it definitely has the all the different legs of the tube that are coming into the middle. And you can see here, Agile modeling, Scrum, Crystal, waterfall, large enterprise Scrum, design thinking. There's a lot going on here. And then DevOps, okay, is obviously very important. Test-driven development right here. And there's also a dynamic version of this. So let me see if I can. I think if I just restart this. There we go. This is the dynamic version where you can see it gets built out. There's XP. Monte Carlo is even part of it. So stochastic simulations. Management, measure, and flow. That's kind of lean. Work in progress. Okay. We don't have to watch all of this, but I just want you to get an idea of how really large and complex this Agile landscape is. Okay. Okay, so again, Agile is a project management approach, but it's much, much more. It's a philosophy and a way to complete technical work, not a set of rigid processes that must be followed. What does it mean to be Agile? What does it also mean to be lean? Lean is another very big buzzword. And you'll hear people on CNBC and on the news, Bloomberg, and they're talking about their company and they're saying, yes, yes, we're being very agile. We're being very lean. So what exactly do they mean when they say those things? So Agile is an approach to manage a technical project, usually software, but now it's being applied in many other disciplines. Finance is taking up, engineering, energy, it's basically promulgating out into basically all of the big industries. It's just a way to think about doing work and getting work done. So I have here in this, and the next slide is what follows. Agile is a philosophy that adheres to the following tenets. And this is what Agile means to me after lots and lots of working in it and research. If you're doing these things, you're being Agile, okay? So number one, emphasize communication between all personnel involved. So however you do that, your lack of communication is one of the biggest ways to stifle a project is where people are not communicating, okay? Agile traditionally focuses on in-person communication. Okay, the Agile manifesto, which culminated in years and years of work and lots of things kind of combined into that, was written around the year 2000. Okay, we'll talk about the history there. So it's not that old, but it utilizes a lot of things that are much older than it, and it emphasized in-person communication because that's the way where the most, the osmotic communication happens, where the most information is transmitted. Okay, whether or not you agree with that, okay, I see both sides there. In today's world, I think we're all in agreement that that's probably not exactly possible, and that hybrid or remote work is here to stay. Okay, so how do we do Agile remotely? And we have great things like Zoom and other video meetings and audio and telecons and chat rooms and Slack and Discord and really, you just need to make sure that you have great communication between all of your team members. I think Slack's a great way to do that. It's a very informal, and I think a lot of things make it into Slack that, and again, we're totally company or product agnostic here, but I think a lot of conversations happen in Slack that would never happen in email. And that's an us. That's part of Agile. You know, communication happens there. You can share files, share data, even put in code blocks. So those types of tools, I think, are great facilitators in communication. The next one is probably one of the most important agile tenets, and that's involve the customer in all phases in the project. So traditional waterfall approaches we're going to talk about, the customer was involved in the very beginning, okay? And then they kind of said, okay, we've got the requirements. Okay, we'll go off, and when you're done, let us know, and we'll take delivery of the product. So maybe 6 months or 12 months or 18 months later, the development team comes back and says, okay, here it is, and there it is, and take it and make sure you pay us. And Agile says, you know, hey, what happens there a lot of times is number one, the customer doesn't exactly know what they want, and the customer is going to change their mind, especially as they see their product and as various iterations happen. They're going to change their mind as to what features they think it should have. So involve the customer in all phases in the project. So the customer is involved from day one until even after it's delivered and there's still, you know, maintenance. Okay, they're involved in the weekly meetings, the product demonstration meetings, where you actually show what features you have working, and the customer's there. And you know, if they're there every week, or even some parts of Agile will say they should be in the office every day. You know, the customer should send a representative to basically hang out with the development team, you know, during the workday, whether or not that's possible. You know, they can't get to the end and say, well, this isn't what we want because we didn't, you know, we didn't have any time to tell you. They've been involved the whole time, so they get to provide their feedback. And down here, customer satisfaction is the measure of success. So we'll talk about what is quality, you know, quality good. You know, what do we actually mean when we say something has quality? Well, Agile just says, look, you're developing software for a customer. The ultimate measure of its success is whether or not they like it. Okay, let's say it only has half of the features that you originally promised, but they're ecstatic and they love it and they, you know, they have no complaints. Then the project is a success. Okay, you know, so their opinion is the ultimate measure of success. So they're involved in all phases and you have their feedback in all phases. Then there should be no reason why they don't like it at the end. Okay. Work in an iterative manner. Okay. We'll talk about sprints, you know, but you know, iterations, sprints, whatever you want to call them, depending on the flavor. It says, hey, look, we're basically going to decide that we have this much time, whether it's 7 days or typically sprints goes 1 week, 2 weeks, 3 weeks, something like that. So let's say 2 or 3 weeks. And over this time, we're going to work on these features because this is what the customer prioritized. They said, we have a big feature list, and they said, these are the ones that are most important right now. And those are the ones we're going to work on. And afterwards, we're going to have a working product that demonstrates those features. And we're going to give a product demonstration to the team and to all stakeholders, including the customer, that demonstrates those features working in action. And we're just going to do that over and over and over again until we're happy. Okay. And well, we're happy, but the customer is happy. Okay. And they say, hey, you know what? I know we still have some features left. Why don't you just go ahead and put a bow on it and deliver it? Okay. We don't care about the other features. Let's just stop the cost now and just deliver it. Agile, you could do that basically at any point. You could basically wrap up your product and ship it. So we say this idea of a potentially shippable product at the end of every sprint, so at the end of every iteration. Have a working product available at set intervals. So that's either at the end of every sprint or every so often you have something that, hey, if the customer says we're out of money, we didn't have as much budget as we thought, just give it to us. You could deliver it to them. Maybe it doesn't have all the features they wanted, but it does work. Well, you work to a feature list or a user story list. So you basically just knock out the features. How granular the features are, that's up to you and your team. And for each feature or for each user story, you put a time estimate on them. How long do you think this is going to take me? That's where the data scientist stuff, and especially machine learning, model building is a little bit more exploratory. It's kind of harder to put a time estimate on how long it's going to take you to train and really come up with the production level model, because there's a lot of uncertainties there about the data and the data sets and how much feature engineering you're going to have to do. So Software development is a little bit more straightforward. Hey, I'm going to make the widget and it's going to change the color when they click or whatever, upload the file. That's a little bit more easier to estimate the time. So, but you're going to put time estimates on your feature list and then try to work to those. You have things like velocity and things, how much you're knocking out each week. Use the correct people. This is another really big part. They can say people. Agile is about people, not processes. Agile, one of its strengths is just says you have to pick the right people. They got to be motivated and highly skilled, and then make sure you can do everything you can to empower them and get out of their way. Because they're gonna, if they're motivated and highly skilled, they're probably don't need a lot of incentive. They don't want to be embarrassed. They want to look good and they want to make a good product. And so if you use the right people, you select the right people for your team, this kind of goes against the idea that engineers or developers are replaceable. Hey, the engineers not coming to work, get rid of them and hire somebody else. It kind of says there's more emphasis on the right people for the job. Okay, people aren't really replaceable, and you got to get the right people for your team. Another big one: embrace the volatile nature of real world projects. So embrace change. Okay, real world is ugly and dirty, and things change all the time, and you have to be able to embrace that. Waterfall doesn't really embrace change that well. It just says no, you have to work to the spec and to the requirements. Flat organizational structure. There's not really a hierarchy in Agile. It's kind of like everybody's on the same level, and y'all are just teammates working towards the same goal. There are sometimes a Scrum master, but they're not really a manager or a boss, so to speak. They're just more or less trying to facilitate the meetings. Customer satisfaction is a measure of success. That's what we already said. That's one of the major tenets of Agile. And also involves subject matter experts and business experts. And data scientists do this. A good data scientist is never going to go off on their own without consulting the subject matter experts to say, does this make sense to you? Do these variables make sense? Are these predictions making sense? Data scientists can get out there pretty lost if they're on their own without consulting the business experts and making sure what they're saying makes sense to the people that really know it. Okay. Empower people to get the job done, remove blockers, give people a good working environment, and then also reflection, retrospective, reflect on how you did periodically, what went well, what went wrong, and improve, and continuous improvement from a Kaizen kind of standpoint. So I said, if you're doing all these things or some combination of them, you're being agile. Okay. So the Agile Manifesto was written in around 2000. This is, I'm just going to go straight to the source here. You can go yourself to agilemanifesto.org. It's very pithy. It's very concise, which is one of the nice things about it. Won't mince words here. So we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value on the items on the right, we value the items on the left more. So what happened is around 2000 in Utah, there was a retreat for developers. You can see the names here. And they all get together and decided what should go into this Agile Manifesto. And then there's more principles here. And they basically reiterate a lot of what I just had on those slides. So I'm going to kind of go back, but feel free to check that out. And it's just agilemanifesto.org. Okay, so one of the strongest pictures I've seen is this one right here, and the next and the following one. Is we say sequential versus overlapping work. So if we look at a traditional waterfall approach, we do the requirements first. And then when we're done with the requirements, then we go to the design phase. And then after the design phase is done, we go to execution and then verification. And at this point, you may not even be testing your stuff until late in the game, and then finally you deploy it. So this is the waterfall. And it has a lot of issues in particular. The late testing and also delivering things the customer doesn't want. So what we're saying is here is in our sprints or our iterations, 4 weeks, 2 weeks, 3 weeks, whatever, we're doing all these things in each sprint, in each iteration. You can see the colors there. And so this sums it up very well. Rather than doing all of one thing at a time, Scrum's team do a little of everything all the time. So we're constantly doing requirements, refining our requirements. We call that backlog grooming, product backlog, feature grooming, design, code, test. We're doing these things all the time. So even in the first sprint, you're testing your code. Okay, why? Because you have to deliver a potentially shippable product. Even if it doesn't do anything except turn on in the first sprint, you get a welcome screen. That's all you get. it has to work. It has to be a working piece of software at the end of every iteration. Okay. Project Management 101. We'll come back to that. I want to show quickly a slide here that also shows Scrum very well. Come down here, this one. This is a Scrum framework. So you have your product backlog, and then each sprint, you pull some of those, you could think of those as features or user stories, and you say, okay, these are the ones we're going to do in this sprint. And you do your sprint. You have a daily Scrum where you stand up and talk about what you did yesterday, what you're going to do today, and what's in your way. And then people try to help you get those things out of the way. And then at the end of every sprint, you have a potentially shippable product increment. And that if after 5 sprints and you're supposed to go 10, the customer says we're out of money, that's okay because you have a potentially shippable product. Okay. I have a lot of slides here on quality and the history of quality. History of waterfall project management goes back probably even to things like the pyramids and roads being built. And anytime humans got together and tried to work together to build large projects. When we talk about quality, we really talk about the modern quality revolution. A lot of it happened in the United States war effort during World War II to manufacture planes and tanks and bullets. And a lot of advancements were made there. And also a lot of advancements were made subsequently to World War II in Japan, in the automotive and other spaces there, Toyota production system and others. So these are, this idea of quality. I'm going to kind of skip over this. How far back do we go to the Industrial Revolution in the UK in 1800, shifted the focus to quantity and productivity. They did inspections at the end, and then they put a pile of good ones, maybe good swords and bad swords or something. And that was the quality control. Let's see, during World War II, quality became very important. And then actually there's some Americans that went over after World War II. America and Japan actually became very close allies, and some Americans went over there and worked to increase quality with statistical quality control methods. They focused on measurement, and this was Edwards Deming. They have a Deming Prize out there for quality every year they give. This led to great advances in quality of Japanese goods, and ultimately America wasn't behind. They did catch back up. Statistical quality control methods focus on data collection, data analysis metrics used to make decisions. So, what gets measured gets done. So measure everything and then make decisions based on your data. So here's Deming. Without data, you're just another person with an opinion. So that was kind of the change. Measure things, use statistics, and now he's honored there in Japan with the famous Deming Prize, which is a global prize given every year for quality. Okay, he was credited with helping take Japan from a completely war-torn and destroyed economy to the second largest economy in the world in 10 years. So 1960, they were the second largest economy in the world after being after World War II. Okay, let's jump down here. Henry Ford, we talk about lean. Lean principle, lean just means eliminate waste. So any way you do that, you're being lean. Henry Ford had been doing these things that they called lean as early as 1920 by just basically shrinking the production cycle and not keeping things like stocked cars on the lot, only just-in-time delivery, those types of things. Okay, let's jump down. Okay, and here's the traditional waterfall. Lean, again, is simply to eliminate waste wherever it is. It doesn't matter if it's meetings or whether it's software or lean just means eliminating waste. Okay, lean manufacturing developed in Japan in the 50s and 60s by Tachio Ono. Lean manufacturing has transformed many traditional concepts. Lean methodology, production should be based on demand, not on supply. It's simply about doing something when someone wants it and orders it rather than doing it first and letting it sit on the inventory. Okay, so it's all about eliminating waste. Let's jump down here. This is a good slide, actually. Here's a summary of many differences between lean and agile. Lean is obsessed with waste, and agile is obsessed with the users and the customer. Lean is manages process. Agile manages uncertainty. Lean delivers value. Agile delivers a working product. Lean applies heuristics. Agile applies principles. Okay, and then the other ones you can see there. There's Deming again, and let's come down here let's apply Agile to data science and AI, or talk about how that can be done. So data science and machine learning model building is inherently exploratory in nature. Okay, if you're just picking a model and trying one set of parameters and then deploying your model, you're not a very good data scientist. You're not going to have a very accurate model. It's inherently exploratory. It's inherently experimental in nature. There needs to be a lot of trial and error. You need to decide, you try different models, try different hyperparameters on those models, try different holdout or test training, cross-validation schemes on how you hold out your data, tweak your model parameters, and you need to be doing that and keeping track of all of that. So that could be quite a lot to keep track of. There are tools that help data scientists do that nowadays, besides tracking in a spreadsheet. Model building, again, exploratory, and it's also iterative. Okay, so we already saw the iterative nature of Agile, and we can see that data science is also iterative. So many parts of data science and AI utilize Agile principles. So this is what I said, things to keep in mind while if you're a data scientist or working in AI and machine learning, try to remain Agile. One, stay close to the customer. Okay. Two, involve the subject matter expert and the business expert. Three, never stray too far from a working product. Okay. You can, you should be able to deploy your model quickly at any time. Don't be scared to change course and maybe scrap your model and go with another one if that is the right decision. Either do your own sprints or iterations for data science work, or have the models as features in the regular sprint. So on that picture we had with the features and the sprint backlog, you could have it that the train and deploy machine learning model is one of those boxes, or you could do your own sprints and iterations as data scientists. It depends on your team. Time estimates are more difficult for machine learning model building than software development, so you have to keep that in mind. So here's the cross-industry standard process for data mining. You can see it's very iterative. It obviously revolves around the data. Starts with business understanding. Okay, it has 6 phases. Data science lifecycle. Business understanding. What does the business need? Okay. Number 2, data understanding. What data do we have? Do we have the right data? Do we need to get more data? Is the data any good? Is it accurate? Is it clean? Data preparation. Number 3, how to organize the data for modeling. That's a large part of data scientists' job. A lot of times they don't even like to do that, but it's something that has to be done. Modeling. What modeling techniques should we apply? What models are good candidates for this type of data? Certain models shine with certain types of data. Okay, so other models do terrible with certain sets of data. So you have to know what models work well and obviously explore. Evaluation, which model best meets the business objectives? And then deployment, how do the stakeholders access the results? What's your production? Is it a dashboard with a machine learning widget, or is it a, deploying something just in time that is resulting from a machine learning model and a prediction, maybe an ad or something? So the 3 things I tell my students about data analysis is, so I teach various courses, including database stuff, is, number 1, know your data. Okay, and that comes from the business subject experience. One of the first things that data scientists, when they get the data, they just start looking at it and ratioing it, plotting it, visualizing it, looking for outliers and things, just to get a sense of what type of data they're looking at. Then being able to access your data. That's often a big problem when you have lots of operational data stores out there, or data sources. You need the data engineering to get all that data into a data warehouse that a data scientist then can sit down and actually access the data easily. Solve that somewhat with feature stores we'll look at, and know how you query your data. Obviously, eventually you're going to need to optimize things like indexing and access to your data and speed of access. So data science is inherently exploratory, hence the iterative nature of this process. Here we've got some slides, KD Nuggets poll. Chris DM is one of the leaders. SEMA is sample, explore, modify, model, assess. Knowledge-driven discovery process for data mining. My own, that's kind of a popular one. Over here, data science poll results, datascience.spm.com. Which process do you use most commonly for your data science project? Again, Chris DM, and then Scrum. Okay, we've talked about Kanban, my own. And then obviously this one, team data science process. I think this is a great infographic. Business understanding is what you start with, and then you can do your data acquisition and understanding. You need to do your data modeling with your feature engineering. This is one of the absolute most important parts of data science and machine learning, is if you can do good feature engineering, you can greatly increase the accuracy of your model. There's lots of technical things there. Model training, which model do you want? How do you do your parameter tuning? How do you do your holdouts and things? Cross validation, model evaluation. How do you evaluate your test data, and how do you actually evaluate your accuracy? Traditionally, some sort of mean squared error or something. Difference between observed and predicted, for your data that you have the results for, you have the solutions for from a supervised sense. Deployment is something that, and over here, here's where you actually get all your data source, pipeline, environment, wrangling, exploration, and cleaning. And then finally, you deploy it to something that the customer is going to want. So here comes back to this idea of the customer. So you should be involving your customer and getting to this deployment. Agile would say you should have something, even if it's not the right model, it's not the best model, it's not the most trained, but you can have something early on that they can look at and say, yeah, if this is as accurate as it can be, we could really use this because this prediction could help us make this decision. So you want to get to this point as early as you can from an agile sense and make sure the customer sees that. They don't have to understand all this stuff about which models you use to feature engineering and stuff, but they should see the end product as quickly. And whether that's an app, it could be an app, it could be a web app, it could be there's lots of different ways you could deliver that to the customer. Here are the tasks in this team data science process. Business understanding starting here, getting the data together, creating the project charter, data ingestion and understanding, and then the modeling. You see here feature engineering, model development, data pipeline, deployment and acceptance. Okay. And then also this is kind of important to have a standardized project structure. So you have your code, you have your project, and then inside your project you have your code. And for a machine learning or data science project, your data is just as important as your code, right? And so that's why we talked about possibly using version control in your data, making sure you maintain data integrity and data quality. You've got your documents, like your basically documentation and things, user guides and such, but that's all part of your project. Feature stores, I'm going to kind of skip over this because we're running out of time. I want to leave at least 5 minutes for questions. A model is only as good as the features it's been given, and a feature store is the kind of a modern way to enable data scientists to share their feature, and the features are the inputs to the machine learning model. So if you can share those and automate that, that's a big that's a big time saver, and that can save a lot of headache. And also, sharing, not just sharing data, but now you're sharing the features. So data scientists, when they're doing feature engineering, they're going to combine and aggregate data and aggregate columns and create features that are inputs to the machine learning model. If you can use a feature store to share those features, and then another data scientist can pick those up and put them right into a model, that's a huge time saver, huge efficiency. So that's automation. Tools, let's see if we can open up. This was the, this is open source version control system for machine learning products, dvc.org. Basically, this is kind of like Git, but for data. Okay. Other tools, we're not going to get too much into the tools here. These are standard tools. I mentioned the feature stores, Docker, Kubernetes, this kind of advanced CI/CD, but MLflow, TensorFlow, scikit-learn, R Carrot library. Obviously, the cornerstones of machine learning and data science are Python, SAS, and some other tools, but are in Python. So to wrap up, regardless of what you're doing, if you emphasize communication between all personnel involved and really optimize communication, I don't care if it's physical or online, or you have Hangouts, Google Hangouts, or you use Slack, or you text message, whatever works. Okay. Emphasize communication between all personnel involved, including the customer. The customer has to be part of that. They should not be getting blindsided and say, I didn't know about this feature, I didn't know about this. They're part of the team. Okay. Work in an iterative manner, have a working product available in set intervals, work to a feature list, use the correct people, motivated and highly skilled people. Agile is about people, not processes. Embrace the volatile nature of real world projects, embrace change, have a flat organizational structure, or relatively flat. Customer satisfaction is the ultimate measure of success. Involve your subject matter experts and business experts, and empower people to get the job done. Remove the blockers, give people a good working environment, and reflect on how you did periodically and improve. Okay, continuous improvement. So what I say to wrap up, if you're doing these things, or you do these things, or you're doing these things, then you're being agile. Okay, so that's it. Let's take some questions. We're about running out of time. I have a lot more material, but that's all we really had time for. So please, any questions? I'll check the chat.
Yeah, thank you, Zane. This was a very interesting presentation. I'm not sure if our audience has any questions. I do have a question. Based on your experience, how closely do you think data science teams follow methodologies like CRISP DM? Because I've seen some companies that maybe get somewhat obsessed over these methodologies, and others that just use them more like guidelines. I don't know what's your experience on that.
Yeah, how closely they're following them. I mean, I think that it's probably going to depend on the team. And I mean, I guess I would say that this is somewhat general in that if you're doing a good job, you're probably doing all this stuff anyway. So
Yeah.
how, it's kind of a question is like, do I need a piece of paper next to me to tell me how to do my job that has a flow chart? No, I know what I'm doing. So they're probably doing it pretty closely, but they're probably not following it as rigidly as, it's like you can have some things like a checklist, like I don't know if they still do this, but pilots, have a checklist and they go one by one and check everything off, or like, a very rigid. I know in the nuclear world, especially, they have checklists and very rigid processes that they have to follow. And they literally, step by step, go through the process and they follow the procedure that's written down. I don't think it's like that. I think it's more of an organic, if they're doing a good job, everything you see on here on the right in this, in the iteration, they're going to be doing all that, right? And
Yeah.
so I think it's some people are different, and they may consult the flowchart or the graphic or the whatever book they're reading on CRISP DM and say, hey, am I doing this? And others are probably a little bit hands off and just it's kind of more natural.
Yeah, yeah. See what you're saying. Someone is asking, as a starter, which of the flavors of Agile would you recommend to get started and build a good foundation?
Yeah, that's a great question. So I don't think I have time. Let me see if I could pull this up. This is the State of Agile report. Let's see. Scrum is number one. So Scrum is definitely where I would start. I don't know if I have the state of here it is.
Did you find it?
Okay, so if you go to, yeah, it's right here. Sorry for the hiccup there. State of Agile. This is a PDF that they produce every year since 2000. Well, I guess since 2005. This is the 15th. You come in here. I thought a lot of this was very interesting because it talks about the trends in remote and hybrid workforces. Only 3% indicate they plan to return to the office full time. 25% they will remain fully remote, and then 56% favor a hybrid approach. Return to the office regularly and not daily. And I know a lot in DC are doing that. They'll go in 2 days a week, and the rest are from home. So work from home. What I wanted to show is Scrum is still the leader. If I could find Scrum, here we go. So see this one. So what should you I like Scrum. We kind of do a very flexible Scrum, and we just basically we meet 3 times a week. Scrum would say you have a daily stand-up. This is when you're working with people in the same office. For 15 minutes at 9 a.m. or 10 a.m. every morning, you just go stand somewhere with a big board that has all of your features and all of your product backlog on it. And you stand there to make it very short, 10 to 15 minutes. And every person says what they did yesterday, what they're going to do today, and what's in their way. And if there's something in their way, everybody works to get that out of their way. So this is what's stopping, anything stopping you. So Scrum, I would start with Scrum. You can see you can combine these. There's all sorts of Scrum Man, Scrum XP hybrid. XP is very focused on, that's extreme programming, very focused on the actual way to develop software, the actual techniques like test-driven development has to be used in XP. You have to do pair programming, which pair programming means you actually physically have another developer right next to you. I think a lot of people, and that does work, but I particularly when I write code, I don't want anybody around me, right? So, but it depends on the person. But for XP, you have to do certain types of ways to develop ways to actually write your software. Kanban is Japanese for signboard, and it's very visual as well. And then you have your work in progress, and basically, you try to increase the flow and pull things, and basically move things from not done to done. Iterative, XP, lean. So point is, the reason I showed this is that Scrum is by far the leader, is by far the majority, and then there's some they combine Scrum and other things. And then the daily stand-ups, obviously very useful. Retrospectives is where you just say, hey, what did we do well? What did we do poorly? And how can we improve? And sprints and iteration, I think, are natural. If you're, I just, every time I was from the beginning, when I started developing software, I had Rev 1, Rev 2, Rev 3, Rev 4, right? And I'm always making backups. Now we have version control, but if you're developing software, you should be developing in iterations. But a sprint would say, okay, here are the features that I'm going to deliver at the end of the sprint. So in 2 weeks, I will have these features done, and I will also demonstrate them to the team. It doesn't always happen, but that's the nature of sprint, of Scrum. And the great visual, you can visualize Scrum in just one slide. This one is a good one. Okay, do we have any other? These are good. Scrum Band. So I'll come back to that one. Slides. Yeah, I'm going to have a condensed version of the slides we can share with everybody on the list and also the students there. Scrum Band. Yeah, you can see some people do Scrum Band. I didn't talk a lot about Kanban. I'll probably have to take that offline. It's very popular, but it's somewhat similar to Scrum. It's also a little bit more esoteric because it doesn't ever really kind of define what you exactly need to do. Scrum, I think, is a good project management approach because it says it's pretty prescriptive and says, hey, have a weekly demonstration, have daily scrums, and then do your sprints in whatever time period you want, 7 to 30 days, and then work. Just basically, you have this product backlog that the customer says, here's all the things that I wish this thing could do. And then by the time you're done, you have maybe 90% of them done, or all of them. Or there's some things even on the product backlog that are always going to be kind of wants, and then maybe you get to them, maybe you don't. And there's others that are more core features. So the idea, though, is that the customer decides the product backlog and the priorities, and then you work the priorities, whichever one are the highest priority to the customer. Is the waterfall methodology? No, it's not dead. So what I always say is I worked in U.S. DOE for the nuclear navy, and they have a very long production cycle. It takes a long time to design an aircraft carrier or a submarine, but they're being agile just over the long term. They're every time they're done with the design and they actually deploy a ship, they say, what did we do wrong? What did we do bad? And then what they do is they make small improvements, and then they do the next design. Okay, they don't start from scratch. So it's kind of a question of building a bridge or a skyscraper or something. Physical things do not lend themselves to iteration as well as software. Software, one of the great things about software is if you screw up, so what? Just run it again. Okay. If you screw up a bridge or a skyscraper, you really can't run it again, right? So there's a little bit different when you're delivering physical goods, okay, or physical things. But even things like that, they're taking the last design and then improving on it, and then doing it again. So they're being agile just over a longer time period. So it's definitely not dead. It's still utilized, but anything in the tech world is going to be trying to be more agile nowadays. The future automates testing software. So software testing is a totally its own, is obviously part of Agile and Scrum, but it's kind of its own thing. And it would be, it's definitely one of the things you're doing. And in Waterfall, you're kind of not doing that till the end. In Scrum, you're doing it, you're testing your stuff during every sprint. So that's why I like this visual. We could talk, please consult us. I also teach a course on software testing. This is CS 551 graduate software validation, integration, version control, software testing. We talk a lot about quality and execution-based testing. So we can't prove a piece of a program correct, okay, mathematically, for anything real life. For very small programs, you probably could, but for anything real life, number of inputs and possibilities, especially when you throw in time, the combinatorics get too large, and we can't prove our program correct. So the only thing that we can do is execution-based testing, and that's actually running our software. And then we have to also have something called an oracle or expected value that says, when I run a test, I will be able to judge whether or not that test failed or passed because I have an expected value. So if you have a calculator, you put in 5 + 5 and you get 10, you say, okay, that's a pass test. If it doesn't get 10, okay, then you say the test fails, something's wrong in your code. And obviously, very simplistic example, but for your, fluid dynamics calculation, calculating a Reynolds number or something, you need to have something that you can predict your expected value to say whether or not that test will pass or fail. And then the other thing with software testing is you can't ever hope to exhaustively test software because there's too many possible inputs. So you're always going to be testing a subset of the possible input domain. And due to that, you always have the possibility of bugs lurking where you did not test. Okay, so testing can reveal the presence of errors, but never their absence, is a quote by Ed Dijkstra, who is one of the fathers of testing theory. It means that you can test and show that there's a bug, but since you can't test exhaustively, you can't ever prove that there are no bugs. Okay, so we don't ever know that in our software. We just hope that the bugs, if they are there, are of very little consequence. There's obviously lots of engineering disasters, plane crashes, bridges, that spaceships and things that basically maybe a software bug did result in a crash and it ended up resulting in human life. But we do, for safety critical systems, we obviously have much more rigorous means of testing. So I hope that helps with the question. Please take all this offline. Stelios and I and the rest of his team are available. We'd love to continue this discussion. We just didn't have enough time to do it all today. So we hope to hear from you and let us help you.
Yeah, thank you, Zane. And I guess we're a bit over time. There are more questions. If anyone has any questions, please send them to that email, which is just pasted on the chat. Once again, round of applause, and we hope to see you again soon to some other of our events. Thanks, everyone. Have a great afternoon or evening, depending on where you're located.
See you, everybody. Bye.